All right, we're going to talk about hydroelectricity today. Just to recap quickly, we talked about biomass and how it includes living organisms or living things, mostly plants. We talked about ethanol and biodiesel and how people in developing countries use wood or charcoal, mostly wood or manure, in order to provide energy. So usually they're cooking indoors, which can be problematic. And then in developed countries, we're using corn and other crops to generate an oil that can be made into a fuel. So now we're going to talk about hydroelectricity. Hydro meaning water. So electricity generated by moving water. And don't worry about this kinetic energy thing. Ignore that. You don't really need to know the types of energy for the AP exam. So it's just generated by moving water. Okay. If we take a look at this chart, we see we've got hydroelectricity generation by country 2011. So this is a little dated, but it's still pretty relevant. And which country is the largest producer? We see it is China. So go ahead and write that in your note packet. China is the largest producer. And if you think back to when we talked about dams, we talked about the Three Gorges Dam in China, right? This is one of the, or it is the largest hydroelectric dam that's been produced. So you can see the United States is down here. Hydroelectricity is really dependent on how many waterways you have, because some waterways are going to be suitable for dams and other hydroelectric projects, and others are not going to be. So if you're in a country that doesn't have a lot of waterways, doesn't have a lot of rivers, you can't use a lot of hydroelectric power. So we know what a dam is. Water is stored in a reservoir behind a dam. So let me pull up this picture here so we can just go through that really quickly. I know we've talked about dams before. So the gates are going to open to a dam, and then they control the amount of water that goes through the turbine. So you'll see on the left side of this picture, this is a reservoir. So they built up this dam. So the water used to go, here's the river, that's where the river used to be, okay? And they put a dam here. So behind this dam, all the water piled up. And so the water level is really high now up there. Okay. What they can do is they can control when they open and close this valve here. So when they open it, it lets water through. And then it spins this turbine. And we know we need a turbine. We need something spinning to generate electricity. And then it just goes down to the lower level of the dam, the other side of the dam. So again, we're still using this basic general idea of we need a turbine to spin to generate electricity. We said that in coal and natural gas and other methods that usually we heat up water and then that steam from the water spins the turbine. Here we're just using water to spin the turbine. So what I want you to do in the rest of the space you have on your note packet, think about some pros and cons of dams. So go ahead, pause the video, think of some pros and cons, write them down. What are the good, what are the bad? You should be able to remember at least a couple. So compare the list you made with this list, okay? So good things provides energy, provides, oops, sorry guys, provides jobs, okay? Bad things, flooding. Okay, so the flooding is usually upstream of the dam, destroys some habitats, releases CO2 when they're constructing the dam, accumulates sediment, okay, hold heat, affects fish migration. So a couple different things there. Choose which ones you want to put down. But I just wanted you to have some pros and cons, so you can pause the video and write down any that you don't have already. So just a reminder, this was the Three Gorges Dam that we looked at a little bit earlier, right? They put in the dam right here. You'll notice there's flooding always upstream, okay? Because all of the water here, if we're stopping, all this water behind here has to go somewhere. So then it ends up flooding. And this is the reservoir that they talk about behind the dam. And then we talked about fish ladders. The reason I bring them up again is because the AP exam loves to talk about fish ladders, right? If we're putting a big dam in, then the fish can't migrate to the ocean or down the river to where they reproduce. So what ends up happening is they put in these little ladders and the fishies jump from step to step, and they're able to go over that dam. Just a picture of a dam. This is the reservoir behind it, right? All right, we also have, for hydroelectric, we can use tidal systems. So tidal referring to the tides. So using the tides to drive turbines, okay? So if we take a look at this picture right here, right? We see there's a little propeller spinning. Well, the tides are created by the moon, right? The gravitational pull of the moon. You may or may not have known that. But what happens is like the waves and the tides come into the shore. So if you are on a beach, let me draw a picture here. So we'll say this whole thing is the beach, and we will draw some water. Here's the water. If you're ever on a beach, what you'll notice is like, this is low tide. Okay, so the water's gonna come up here to the beach. And over the course of a day, the water changes where it is on the beach. So during high tide, it maybe travels up to here, and so the water goes up to here on the beach, and then it retreats and it'll go back to low tide. So the tides create this push and pull of the water. So what happens is when the tides come in, they spin the turbine this way, and when they come out, they spin the turbine that way. Again, we just need a spinning turbine to generate electricity because it's going to spin the generator to generate electricity. So the only problem here, disrupt ecosystems. I know that's not very specific, but think about it. Destroy habitats. You know, what about fish coming in here? What about noise? Is it noisy? And then the difference between the low tide and the high tide, it's not enough to provide like tons and tons of energy, like a dam, okay, or like a coal power plant. So it can provide some energy, but not a huge ton of energy. So hydroelectric, two different types. We've got dams and we've got tidal, okay? And then we're going to talk about solar, and then we'll be done for today. Here is just a picture of a couple different tidal systems. This was in National Geographic. So there's actually one, I'm only going to talk about 3 of these. There's 4 in the picture, but here are ones that we saw. These are called fans. You don't necessarily need to know the name, but they look like mini wind turbines underwater. Okay. They also have something called, they call these kites. Why do they call them kites? No idea. But it's more of these big scale fans. They kind of look like some of the fans you've seen. And then there's also another one. These are called paddles. And what happens is this flap here goes up and down with the tides, and it generates electricity that way. So basically we need moving stuff in order to generate electricity. And a lot of times the stuff that's moving is going to be going in a circle. All right, so now we're going to talk about solar energy, okay? So they usually like to ask about passive versus active solar. So there's 2 types of solar energy, okay? The first one is passive. Passive, if I'm a very passive person, it means, oh, I'm not going to get in anybody's way. I'm just kind of going with the flow, okay? So passive solar energy, energy captured without using pumps or technology, okay? Basically, like this picture shows, with active solar power, you've got like solar panels, you got a bunch of technology. Passive, you're just going to design your house so that it's can harness as much solar energy as possible, okay? So for example, you could even think of like a greenhouse as being passive. It doesn't use any technology, but because we design it all in glass, it allows the light to come in and it heats up that area. Active uses technology, okay? So it uses those solar panels that you've seen before. There are some examples we'll talk about. You don't have to write down these examples, but I'll show you on the next slide. So passive is just building your house in a way that captures sunlight, okay, and captures heat from the sunlight. Active means we're going to use technology, solar panels, in order to capture that light. So let's take a look at some elements of passive solar design, okay? I don't know that there's a place for you to write some elements of passive solar design, but if you just want to jot them in the margins, just a few things to like give you a reminder of what some of these things are. So let's take a look. So skylights, okay? We can have skylights to let in light. We know that if we let in more sunlight, it's going to heat up our house quicker, okay? It's going to heat up our house more. So by having a skylight, you're not going to heat your entire house, but you might reduce heating costs a little bit because some of that sunlight's going to come in and it's going to be able to heat your house a little bit, okay? So they're also talking about an equator facing window. So a window that faces the equator, or a lot of times, I believe they say, let's see here, I was gonna look, nope, sorry. So the equator facing window, and that's because you're gonna get the most amount of sun based on how the sun orbits, or how the earth orbits the sun. We wanna make sure that we have a lot of insulation. You'll see that sometimes they'll have trees to help shade it and keep it cool. So that's going to reduce AC costs in the summer. Here's another picture here. Okay. Light colored roofs. You guys know that if you have like a black car, it's going to heat up more than a white car. Or if you've got like a black shirt, right? It absorbs more sunlight than the white shirt. It gets hotter faster. So light covered roof. A lot of times we will have an overhang here, and that helps prevent the summer sun from getting in when it's really hot, but allows the winter sun to get in, okay? So these are all some things that go along with passive solar design, meaning designing your house in a way to optimize the amount of energy coming in from the sun. With active, so over here on the left, you'll notice there's a lot of other things, like we've got solar panels and we've got this pump and a hot water tank, and these are all technologies that are being used to help capture sunlight, okay? So you can do both, you can use both, but it's just showing you the difference between passive and active. So one of the things you can have a solar water heater, okay? This is one of the active technologies we can have in a house. So we've got these panels, and they're going to heat up water. So they heat up the water here, and then you use the water, and when you use it, it becomes cold again, and eventually we have that cold water either goes to a sewage treatment plant or whatnot, and then the new water, the blue, the light colored, the cold water comes back in, right? So cold water comes in, it gets heated up, warm water, and then you're using it for what you need to use, like a shower. All right, photovoltaic solar cells. These are abbreviated PV cells. So these are the solar panels that you guys know, okay? You could write solar panels in here. So they're made of materials that emit electrons. So they release electrons, and then they create electricity when they're exposed to sunlight. So you might ask, how exactly does this work? Well, I'll be honest, I can't tell you all the ins and outs because I myself do not know them. Here's what I do know. I know that when the sun strikes the solar panel here, you can see a close-up, it releases electrons, okay? We need electrons to be released in order to generate electricity. That's what electricity is. It's electrons. That's what we call electricity. So this material, it's such a material that's made in a specific way so that when the sunlight hits it, the electrons are released and then they're captured and put into basically wires that can power light bulbs and other things in your house. The other one we have, this you would not put in your house, But this is what you might do in a really big area, okay? So concentrating solar thermal systems, or CST. So it uses lenses or mirrors. So take a look here. Here's all of our mirrors. This is a huge area. Like, look at, these are all little cars down here. So this is huge. So you want to do this in an area where there's a lot of open space. So it focuses, all of these little lenses are focusing the light right on this beam. So they're all angled at just the right position. And then this beam takes all of that energy, right, all of that heat, to heat water, produce steam, turn a turbine, and generate electricity. Okay, so it's kind of a crazy thing to think about. If you've ever taken a magnifying glass and tried getting the sun to go through the magnifying glass, and you'll notice it like concentrates the beam. It's kind of the same idea. Okay, so all of these are pointing their light so that the light is super concentrated here and can heat up this water really, really quickly and then generate steam and turns a turbine. The only problem is you need a huge, huge area to do it. And like all solar, you can't generate electricity at night. So there has to be the sun out. All right, so let's take a look at solar power. So first of all, some pros. No air pollution, that's a good thing, right? We're not emitting CO2, we're not, this is a renewable energy source, so there's no air pollution involved. Here's the problem, it's really expensive, okay? So if you take a look at this graph over here, it says the average payback is 7.5 years, meaning if I buy a solar panel, okay, and let's say I buy some solar panels for $10,000. It's going to take me 7.5 years to save $10,000 on my energy bill. So it's going to take me 7.5 years to use all of that money that I'm saving because I'm not using as much on electricity generated by coal or whatever, 7.5 years to pay it off. You can take a look though at this graph down here. PV cells, notice the price is definitely decreasing. So that's a good thing, all right? Making them takes a lot of materials, so a lot of water, energy, it's a lot of toxic metals. So if you think of like a solar panel, it's got a lot of metal and a bunch of other stuff in it. So producing it is not necessarily the best. It's really hard to dispose of PV cells or the batteries that are used. And sunlight's not always available. Think about it. How many days out of the year is it cloudy here, right? Quite a few. And if you can't generate a lot of power when it's cloudy, that's a problem. So I just want to take a look here. Notice this is a map of the United States. So if we take a look, this shows us which areas receive the most sunlight, okay? So lighter color is less and darker color is more. So you'll notice which part of the US would be best for solar power, like the Southwest, right? So they're the ones that consistently get the most sunlight. And they have the most days that are not super cloudy. So definitely there are different places that have more or less potential for solar power than other places. So something to keep in mind. If we take a look at solar energy production by country, just for fun, we see that Germany and Italy are really high up there. USA, we're number 3, but we're not super high up on the list. We're just number 3. So just to give you an idea, this is all of these are expected to increase. So more countries are going towards renewables and will have more solar energy production likely in the future. Blah, blah, blah. All right. And then next time we talk, we'll be on Thursday and I will do the rest of the note packet then.